This skill module covers overview of reservoir engineering for facilities operations at the core knowledge level. This section discusses why this topic is important. What will this module help me do? Why do I care? Understanding what a trap consists of, how it is formed, and what problems it may cause is important to prevent loss of recovery of petroleum fluid, which may result in loss of revenue. If there is an impervious rock layer that forms a barrier to prevent the escape of hydrocarbons from a porous and permeable layer, the oil gets trapped and cannot squeeze out to reach the surface. By understanding trap structure and formation conditions, we can choose a suitable mechanism to break the barrier and bring the petroleum fluids to the surface, separate the phases, remove the contaminants to meet sales specifications. Understanding important reservoir rock properties like porosity and permeability, drive mechanisms, inflow, outflow, nodal, and artificial lift is critical to ensure that the facilities are designed with the right equipment and/or chemicals to prevent loss of production and loss of revenue. Why is this important to know? What problems will I solve? This skill module presents 4 topics which help understand how petroleum fluids flow from within the reservoir porous rocks to the surface facilities naturally. Sooner or later, the reservoir pressure declines and driving forces run out of energy, and a significant amount of petroleum fluids will remain underground. Understanding the 4 topics covered here will help you to maximize oil production rate and minimize the operating costs. The 4 topics covered in this skill module are reservoir traps, rocks, and drive mechanisms, reservoir fluid classification and phase envelopes, inflow performance relationship, and artificial lift. What could go wrong if you didn't know this? What could go right if you do know this? If we do not understand the mechanism, required utilities and maintenance, and well characteristics and operation conditions in our well or process, then we run the risk of potential damage to the main equipment and downtime. Production will go down, and we may be at risk of having an extended shut-in to try to repair or replace the equipment. On the other hand, by applying a suitable artificial lift type for our well, we can have stable production with low operating cost, thus maintaining production revenue. What is or are the business impacts or consequences of this topic? For example, efficiency, cost, profit, production, quality, reputation. Understanding the mechanism, required utilities and maintenance, as well as the well characteristics and operation conditions of our well or process is critical to ensure that the facilities are designed with the right equipment and/or chemicals to maintain the desired production rate. What is or are the safety impacts or consequences of this topic? For example, for people, environment, security. Overpressure, under-design rating, inadequate specification, and incomplete or inappropriate hazard reviews have caused many injuries and fatalities.